Hello class, this is Mr. Sutton, and today we're going to be doing Skill 26, Polynomial Terminology. This is a bit of a review skill, some stuff we have talked about before, but we are going to be covering it again in maybe a little more depth to kind of get you prepared for your final at the end of the year. So here is some vocabulary for you to write down in your notes. So first we have terms. Terms is a mathematical expression separated by addition or subtraction. So for example, I have 6x plus 7y. This is a term and this is a term. So we have two terms here. Polynomial, expression consisting of one or more terms with constants, variables with whole number powers, and coefficients. We'll get into some more examples of polynomials in a moment because there's lots of examples I could give. A monomial is a polynomial with exactly one term. So if I just gave a constant like 7, that's a monomial. Or you could say 8x cubed, that's a monomial, only one term. Binomial, polynomial with exactly two terms. So like this example up here that I gave is a binomial. Trinomial, polynomial with exactly three terms. So your quadratic, this is a trinomial, has 1, 2, 3 terms. A lot of quadratics that you're given are trinomials if they have this middle term. If they don't, if it's maybe a difference of squares, that's a binomial, right? And then degree is the largest power of a variable in a polynomial. So this, for example, has a degree of 2. This has a degree of 2. This has a degree of 3. This has a degree of 1. This 7 here has a degree of 0, right? Because we don't have any variables to exponents. So make sure you have these definitions written down in your notes, and we're going to go through some more examples throughout the video. So there's kind of a table of examples showing you how to classify these things. So you can classify a polynomial by the number of terms it contains. A polynomial of more than 3 terms does not usually have a special name. You can also classify a polynomial by its degree. The degree of a polynomial is the greatest degree of any term of the polynomial. The name assigned to each degree is listed below. So basically they're saying we don't go above trinomial. After that we just call it a polynomial. It's a little more generic. But we can also classify these polynomials by the degree. So let's look through these examples. So here's an example of a polynomial that's just 6. So it has only one term, so it's a monomial. And the degree is 0, right? We have, let's say, we could say that we have x to the 0 power, right? X to the 0 power is 1. So basically it's just like an invisible x to the 0 power. And the name using that degree, so since it has a degree of 0, we just call it a constant. Another polynomial example, x plus 3, 2 terms here, 1, 2. So that means it's a binomial. The degree here is 1. This has to be x to the first power. When the degree is 1, we call that a linear polynomial. Right. Here we have 3x squared. Only one term here, so it's a monomial. The degree is 2. When the degree is 2, we have a quadratic. Here we have 2x cubed minus 5x squared minus 2x. 3 terms, 1, 2, 3. So that means it's a trinomial. The degree is also 3, right? 3 is our highest exponent here. So that means it is a cubic polynomial. When the degree is 3, it's cubic. Another example, x to the 4th plus 3x squared. 2 terms here, so it's a binomial. The degree this time is 4 because that's our highest exponent. So that is a quartic polynomial. And then last example, negative 2x to the fifth plus 3x squared minus x plus 4. We have 1, 2, 3, 4 terms. So that's just polynomial, 4 terms, no special name there. The degree this time is 5 because our highest exponent is 5, and that is a quintic polynomial. So the new information on this slide is this column here. Which just tells you how the name of using the degree. So for 0, we have constant. For the degree of 1, we have linear. Degree of 2, quadratic. Degree of 3, cubic. Degree of 4, quartic. Degree of 5, quintic. So definitely make sure you have this information down, but you also probably want to have these examples down as well. And then the last piece of information for your notes before we get into some delta math examples is standard form. Making sure your polynomial is in standard form. You want to combine like terms, so terms that have the same exponent with the same degree, or excuse me, the same variable with the same degree. And you also want to order your terms from highest degree to lowest degree to put it in standard form. So let's go ahead and once you have this down, we're going to go to delta math and look at some examples. So first we're going to start with classifying polynomials. Determine if the expression negative 2 is a polynomial or not. If it is a polynomial, state the type and degree of the polynomial. So negative 2 is a polynomial. This is a constant. Polynomial has a degree of, or the polynomial is a monomial, right? Only one term here, and has a degree of 0. All right. Let's look at another question here. All right. This one has more terms. But this one, notice it has this negative 5 here. So an important part of the polynomial definition is we have to have just whole number exponents. So this negative 5 makes it not a polynomial. The other thing that could make it not a polynomial is if we have a there we go. If we have our variable underneath a square root, what is going on here? Can we draw? Okay, I guess I have to draw bigger for it to work. So if you have your variable underneath the square root, that also makes it not a polynomial. So let's go ahead and answer this one. Does not represent a polynomial, then you have no other questions to answer there. So let's go ahead and check this out. So yeah, exponents of the variables in a polynomial must be whole numbers, 0, 1, 2, 3. If there's a negative exponent on a variable, the expression cannot be a polynomial. So those are things to look out for these, either negative exponents or variables underneath a radical. I'm going to try to find an example like that. Here's a good one to look at. This one has a radical, but notice that we just have a constant under the radical, so that's okay. We can have polynomials with constant under a radical. It's only when the variable is under a radical that it's not a polynomial. So this is a polynomial and it's a binomial. We have two terms here, 1, 2, right? Because they're separated by subtraction here. So this is a term, and this over here is all one term, and it has a degree of 4, right? We have an exponent of 4 here. All right, here's the example I was looking for. That's also not a polynomial. So this time the radical contains our variable. We have this a underneath the square root. So this is not a polynomial. because our variables have to be whole numbers, exponents of 0, 1, 2, 3, etc. Since the expression square root of a can be written as 1/2 a to the 1/2 power, then it cannot be a polynomial. Now we're going to look at some polynomial vocabulary questions, answer the questions about the following polynomial. So this expression represents a quadratic, because we have a degree of 2, and there are 2 terms. The constant term, so the constant term is just the number that has no variables, so that would be 10. The leading term would be, if you wrote this in standard form, what would be in front? So that would be this x squared over 6. So I'm going to do x squared divided by 6. And the leading coefficient would just be the coefficient for that leading term, which is the number that will go in front. So that's 1 divided by 6. Let's go ahead and submit this. All right. Let's look at a new one. So this represents a linear polynomial because our degree here is just 1. Right? So remember that makes a linear polynomial. This has 2 terms. Constant term is that 1 divided by 6, because that is the variable that has no that's the term that has no variable attached to it. Leading term is, if you put it in standard form, the term that would be first. So this is where it's the one that has the highest degree, so that would be 6x. And so if you put it in standard form, it would look like this, right? Highest degree to lowest degree. So the leading term would be 6x, that first term. So then the leading coefficient is just the coefficient of that leading term, which would be 6, right? Just the number that's out in front. Highest power is 1, so polynomial is linear. Polynomial has 2 terms, 6x and 1/6. Constant term is the term with no x. 1/6 leading term is the first term in standard form, or the term with the highest power of x, 6x, making the leading coefficient 6. Last type of question is to just rewrite in standard form. So remember the rules. We want to combine like terms and then order from highest term, the highest degree to lowest degree. So highest degree would be 3 here. So we have x to the 3rd divided by 5. Next highest degree is this x to the 1st. So you gotta make sure you keep your signs with it. So that's a negative x. And then last we have that negative 10. All right. Let's look at this one. Highest degree I'm saying is this 8x to the 4th. And then next highest degree would be this positive 2x squared. And then we have this x out in front. Note that it's a positive x, so we want to have a plus sign out in front of that. And then this 1/6 is negative, so negative 1/6. So you got to keep your signs with the terms. You don't want to move the signs around. Let's look at one more. Yeah, so like this one, x to the 4th that's our highest degree. And so this is negative 5x to the 4th. So we got to keep that negative with the 5x to the 4th. And then we have 8x to the 3rd, which is positive. So we got to keep that plus sign with it. 8x to the 3rd. And then negative 2x. Keep that negative sign with it. And then this 1 is positive. So plus 1. All right. If you have any questions about any of this material, make sure you ask your teacher for help. Go to office hours and make sure you have a good day.